Heating and air conditioning, HVAC, residential heating and cooling, concepts of a heat strips with as it pertains to a heat pump. These strips here are part of what they call the heat strips. They're coils that get red, get cherry red, they get hot and produce heat. A fan blows and blows air throughout the home if everything's working efficiently, properly, and in correct order. So the heat strips, now keep in mind there are a multitude of different size heat strips. This particular size here is a 5K, but there are 5K, 10K, 8K, and I'm not certain how many. There may be a multitude, I'm not certain, but someone would have to, they can add that to the comments. But the ones I see are normally 5, 8K, and 10K heat strips. So basically, I call this resistive heating. I'm not certain if that's the correct term. It heats up, causes resistance, gets red, and this is what causes the heat. This comes on perhaps in auxiliary mode, or emergency mode via the thermostat. Aux, like I'm assuming is the truncated version of auxiliary. The word meaning auxiliary means helping, like an auxiliary verb means a helping verb. So it would help it when it goes into defrost mode. If one throws this on to emergency heat, then at that point the outside condenser may be locked out, and this is your sole heating source. So the following month, when you open your power bill up, if it's a paper power bill, and if it's been cold, the temperature is plummeted below 32 for an extended length of time, and all of a sudden you get an extremely high power bill, this may be the reason, because it does use a lot of electricity. So this is not technically anybody's fault per se. It is what it is. So but if you do run it in emergency heat, keep in mind that power meter may be turning. So but notwithstanding, this is a 5K heat strip. The topic of this conversation is we're going to use an ohm meter. We're going to put it in ohms, which is this little horseshoe symbol here on this meter. We'll turn the backlight on so we can see it. Says, oh well, that's just different meters have different configurations. But so now keep in mind, if this coil were broken, it may read OL. So we will put one lead over here. We will put one lead here. Put it here. And we go up here to the next prong. And we put it here. And when we do, we're reading about 11.6, 11.5, 11.6 to 11.7 ohms. And again, the ohm symbol is this little horseshoe configuration that measures resistance. So now I took the lead off. We have OL. If we had a broken line, it may or may not. Somebody can add that to the comments. I'm under the impression that it may read OL if one of these coils were broken. And they do get burned. They get metal expands, contracts, gets heat, and that sort of thing. They get wear and tear. So now we've got this lead here. We go over here, and I put this on here. And once I do, again, we're reading, well, that one pops up to 12.1, but it's in the 11.5 to 12 range, somewhere thereabout. So touch it again, and we get somewhere thereabouts. It depends on how good the connection, 11 point something to 12. So I'm under the impression that these heat strips may be good. If they were bad, they may read OL. So just a quick way to ohm out the heat strips to see if they have resistance. And so these are heat strips for a heat pump. These are a 5K. Again, they're different sizes. One needs to size the wire and the breaker according to the size. 5K meaning 5 kilowatts. So this is used for a heat pump, not a gas furnace. Again, heat strips for a gas a heat pump, not a gas furnace. Thank you for watching and have a wonderful day.